Welcome to the deep dive, right here on the A of Think channel. It's great to have you with us. Just take a moment, think about the sheer amount of information, that data, hitting us constantly.
It's overwhelming, isn't it?
Totally. From sensors or phones, business operations, scientific research. It's just vast.
Well,
But the real question is, how do we actually use it? How does all that data become, well, useful?
that really is the core question, and that's what this deep dive is all about, drawing directly from the material you shared with us. We're looking at how we apply algorithms to turn that raw potential into actions, part of a bigger picture, really.
Looking at data's role in our time.
Exactly, defining its role.
So our mission today is to unpack that whole process. How algorithms actually bridge that gap from having, unprecedented amounts of data to getting real value or insights.
Let's dive in, focusing purely on the insights from the sources provided. The material actually describes right now as this extraordinary intersection.
An intersection, okay.
Yeah, and the key feature, an unprecedented volume of data. It's just everywhere.
It really feels like that, constantly generated. And the hardware keeps getting smaller, more powerful.
Right, and our computers can process and analyze it faster than ever before, which is, accelerates the whole cycle.
The spread and growth.
And this explosion of data has fundamentally shifted something really important. The value of data.
How so? It's not just for record keeping anymore, like old company databases.
Well, that's still there, of course. But its primary value isn't just operational anymore. It's increasingly seen as a means to create new values.
So less static record, more dynamic ingredient.
Precisely. It's the raw material for new insights, new services, completely new ways of approaching problems.
Okay, so how do we unlock that new value? Storing and organizing is one thing, but the sources point elsewhere for the real engine, right?
Yes, the absolute key is the use of the data itself through intelligent algorithms. That transformation turning passive data into something active and valuable. That's why people call it the new oil. It fuels these intelligent processes.
Right, the new oil analogy. Makes sense. So data's the fuel. Algorithms and AI are the engines.
You could say that. They're the sophisticated engines figuring out what to do with all that fuel.
And that relationship between data and AI has evolved, hasn't it?
Oh, absolutely. AI itself has gone through phases, Simple algorithms, then symbolic reasoning, expert systems.
The neural networks, deep learning.
Exactly. But the sources highlight a really key shift. It's not just about feeding data into a predefined algorithm anymore.
What's the change then?
The fascinating part is that the data itself now actively shapes algorithms. It helps make them useful for specific tasks.
So the data isn't just passive input.
Not anymore. It actually helps train or tune the algorithm. It's involved in creating the solution.
That's a powerful idea from the sources, data becoming the craftsman of the solution itself, not just the material.
It really underscores this symbiotic relationship. Smarter AI, modern AI, it critically depends on data. The algorithm learns from it.
Okay, so let's get down to basics. What are algorithms actually doing with the data? What are the fundamental processes?
Well, they're the active agents, right? They analyze it, process it, filter it, transform it.
Organize, store, retrieve.
All of that. They take the raw stuff and manipulate it into something meaningful or structured.
And the sources mention different types of algorithmic approaches. It's not just one method.
Definitely not. They cover a range, like expert systems. These use rules, often based on human expertise.
Rules like, if X happens, then do Y.
Kind of, yeah. They can work forward from the data-driven or backward from a goal-driven, using a knowledge base.
Then there are search algorithms. The sources mention BFS and DFS.
Right. Breadth first search and depth first search. These are ways to explore structured data, like trees or graphs. Think of finding a path in a maze or possibilities in a game.
Systematically exploring the options.
Exactly. And sometimes finding the absolute perfect answer is just too hard or takes too long.
Computationally expensive.
Right. So the sources mention local search and heuristics. These are about finding good enough solutions, iteratively improving things.
Practical answers, even if maybe not the mathematically optimal one.
Precisely. And then we get to the approaches that really embody that data as craftsman idea, machine learning and deep learning.
This is where algorithms learn from data.
Yes, the sources point specifically to deep learning. You have data flowing through these layered neural networks.
Like interconnected nodes?
Sort of, yeah.
Yeah.
And the network adjusts its connections, its weights, based on the data it sees and the errors it makes. It learns to perform a task, like recognizing a face or translating text.
Using things like backpropagation to adjust based on mistakes.
Exactly. The data literally guides the algorithm to get better. It's fascinating stuff.
It really is. And, if you find these kinds of discussions fascinating, definitely consider subscribing to the Eye of Think channel. We try to break down these complex topics regularly.
Yeah, it's a great way to stay updated.
So we have these different algorithmic approaches. Where are we actually seeing them in action? The sources give a ton of examples.
They do. The applications are incredibly diverse. Think about just everyday life.
Like what?
Credit card fraud detection. That's algorithms analyzing patterns.
Yeah.
Resource scheduling, making sure things run efficiently. Pattern recognition in images, sound.
Language processing too, right?
Yeah.
Understanding text, translation.
Absolutely. Game playing AI, even things like automatic correction, spell check, grammar suggestions, driver assistance systems in cars.
Making tasks easier or making us more efficient.
Exactly. Then look at the medical field. Huge impact there.
How so?
Patient monitoring systems, analyzing radiological scans like X-rays or MRIs, spotting things humans might miss, assisting in discovering new drugs.
Managing medical records too, I imagine. That's a lot of data.
A massive amount. And algorithms help make sense of it. They're also used for predicting patient outcomes, trying to make procedures safer, optimizing drug administration.
Wow, really wide-ranging. What about transportation? We hear a lot about AI in cars.
Autonomous vehicles are a prime example. Algorithms are doing everything.
Everything.
Well, almost. Planning the route, predicting what other cars or pedestrians might do, that's environment prediction, deciding the car's actions, stay in lane, change lanes, follow traffic rules, behavior planning.
And the actual physical movement.
Trajectory planning, yeah. How the car steers, accelerates, brakes. And all of this relies constantly on processing data from sensors, cameras, LiDAR, radar.
It's a complex dance of algorithms, even beyond Earth, right? Space?
Yes. The sources mentioned using algorithms to help observe the universe, plan exploration missions, potentially mine resources on asteroids or planets.
Managing habitat, scientific experiments.
Right. And space AI often needs more autonomy. It has to learn from its environment and solve unexpected problems because, you can't just call mission control instantly.
Communication delays make real-time help tricky.
Exactly.
And back on Earth, our actual work lives.
Algorithms are showing up there too, assisting with recruitment sorting resumes perhaps, optimizing work schedules, helping businesses identify problems or requirements.
Providing adaptive help, like personalized training.
Yeah, adaptive learning systems for employees is becoming quite integrated.
It's really clear that algorithms fueled by all this data are, changing things everywhere. But the sources don't just paint a rosy picture. They talk about challenges, big ones.
Absolutely. They're very grounded about the hurdles.
Yeah.
And the first major one they dig into is data quality.
Right. Data isn't perfect. What kind of problems are we talking about?
Well, the basic issue is raw data often just doesn't work well for algorithms. It needs a lot of cleaning, shaping, manipulation.
Pre-processing.
Exactly.
Yeah.
Plus, there are limitations in how we even collect data. And a lot of big data is unstructured text, images, video, which is harder for algorithms to use directly.
And reliability is an issue, like errors or inconsistencies.
Huge issue. Inconsistency, security vulnerabilities, even the possibility of data being deliberately messed with.
And simple human mistakes, typos.
Oh yeah, typing errors, formatting inconsistencies, they creep in all the time. Then there's missing data. Sometimes it's random gaps, sometimes it's whole sequences missing.
And trying to combine different data sets that don't quite match up.
Misalignment, yeah, that's another headache.
The sources also mentioned something called data untruthfulness. That sounds bad.
It is. It's not just random errors. It includes commission, basically, deliberate lies or falsified data, and omission, leaving out critical facts.
Wow.
And closely related is the massive problem of bias in data. Historical biases, societal biases. They get embedded in the data we collect.
And if the data is biased,
The algorithm learns the bias
Yeah.
and replicates it or even amplifies it. It's a serious ethical challenge.
definitely. Any other data issues mentioned?
Yes, from the frame of reference problem, you might have accurate data, but without the right context or real-world understanding, you could interpret it completely wrong.
So data doesn't speak for itself entirely.
Not always. And the sources also just mention general fallacies that can occur in how data is gathered and interpreted.
Okay, so getting the data right is a massive challenge in itself. What about the algorithms and AI? They have limits too, right?
Oh, absolutely. The sources are clear on this. Firstly, not every problem can be solved with an algorithm. Some things are just too complex or inherently unpredictable.
And even for solvable problems.
Even good algorithms like local search might get stuck in a suboptimal solution, or they might just take way too long to find the best answer.
Practical limits.
Right. And things like expert systems. They're limited by how well you can actually capture complex human knowledge in simple rules. It's often harder than it sounds.
And modern AI, deep learning. It's powerful, but not magic.
No, definitely not. As we touched on, it usually needs data to be heavily pre-processed. It generally can't just take raw, messy reality and make sense of it directly. Not yet, anyway.
And there are deeper limitations, too.
Yes, and this is critical. The sources emphasize that current AI fundamentally lacks innovation, creativity, and imagination.
That's a pretty fundamental gap compared to humans.
It is. AI, as we have it now, can't truly sense the world like we do. It can't understand complex emotions. It can't empathize. It can't develop its own motivations or goals.
It's bound by its training data.
Completely.
Yeah.
It can't generate truly new ideas outside of the patterns it learned. It won't recognize something genuinely novel if it's too different from its training.
And it's all just numbers and patterns to the AI. No real understanding of context or consequences.
That's the core of it. It manipulates symbols or numbers based on correlations in the data, but it doesn't understand the meaning behind them or the real-world impact.
Which is why the sources say humans still outperform AI in many tasks.
Exactly. Tasks needing deep understanding, common sense, nuanced judgment, real creativity. Humans are still essential.
Okay, so data challenges, AI limitations, anything else?
Yeah, the sources briefly touch on expectations and regulation.
Meaning?
Sometimes people just expect too much from AI too soon. Unrealistic expectations. This has happened before.
The AI winters.
Right. Periods where funding dried up because the technology didn't live up to the hype. Managing expectations is important.
And regulation.
As AI gets deployed in critical areas, autonomous cars, medical diagnosis, financial systems, drones, we absolutely need to think about the rules. Safety, accountability, ethics. These are huge societal questions.
We need frameworks for how to use this technology responsibly.
Definitely.
Okay, so it's a complex picture. On one side, algorithms are vital. They unlock value from data, power amazing applications everywhere.
Essential tools, as the sources say, for making data useful.
But on the other side, serious challenges. Data quality is a minefield. Current AI has real limitations, and we need to manage expectations and figure out regulation.
That captures the essence of what the material presents. It's not simple, but algorithms are that crucial bridge from data potential to actual impact.
And this deep dive, sticking just to the material provided, hopefully gives you, the listener, a clearer view of both the power of that bridge and the difficulties in building and using it.
Yeah, success isn't just about fancy algorithms. It's about deeply understanding the data, its flaws, and the real limits of the AI you're using.
It's a constantly changing field. We've gone from the idea of data value to specific examples and the tough realities of making it work.
And knowing those realities is just as important as seeing the potential.
Absolutely. Which brings us to a final thought, really stemming from everything we've discussed based on these sources. Given AI's incredible power derived from data, but also its fundamental lack of things like creativity, empathy, true understanding, how does that shape the future? What kinds of problems should we be applying these algorithms to, especially the really complex, deeply human ones?
That's a crucial question to ponder as this technology weaves itself deeper into our world. What are the right applications and what are the risks?
Something for all of us to think about. We really hope this exploration of applying algorithms into action based on the source material has been insightful for you.
Keep digging into this intersection of data, algorithms, and intelligence. It's shaping so much.
And if you found this valuable, please consider sharing it with others who might be interested. And definitely subscribe to the A of Think channel for more deep dives like this one. Thanks for tuning in.